find the equation of the tangent line to a polynomial and a point. Alright, so for our first example here, we want to find the equation of the tangent line to the function f of x is equal to 4x cubed minus 7x squared plus x plus 9 at the point 1, 7. As you know from a previous video, we want to start out with our equation of the tangent line, which is y minus y sub 0 is equal to m times x minus x sub 0. And we said that this is the point-slope form of a linear line, which means the two pieces of information we're going to need to find are the slope and then the point. So let's just do a little bit of scratch work on either side here. Alright, so to find the slope, we know that the slope is equal to the derivative of our function. So we can start out with our function f of x is equal to 4x cubed minus 7x squared plus x plus 9. And this is a polynomial here, so we can take the derivative by using the power rule and the sum and difference rules. So therefore f prime of x is going to be 12x squared minus 14x plus 1. Alright, now this derivative is the formula we can use to find the slope at any point on this function. However, we don't want to find the slope at any point, we want to find the slope at a particular point at 1, 7. In order to do that, we need to identify what our x value is, and we can see from the point the x value here is going to be 1. So we need to find the slope at 1, so that means we'll do f prime of 1, and we'll replace all the x's with 1's in our derivative. And then we can simplify this to be what? 12 minus 14 plus 1, which will give us a slope of negative 1. Alright, and then we do need to find our point. And fortunately for this particular problem, we are actually given the point. We don't need to substitute the x into the function to get the y. So we know that x sub 0 is going to be 1, and y sub 0 is going to be 7. So I can plug all this information into the equation of the tangent line to get y minus, we said y sub 0 is 7, and that's going to equal our slope, which we said was negative 1, times x minus our x sub 1 value, which is 1. Now, this is a perfectly acceptable equation of a tangent line. However, sometimes Newton does like you to put it in slope-intercept form, so we're going to go ahead and do that right now. So first thing we're going to do is we're going to add the 7 to both sides to get the y by itself. And this can give us y is equal to negative 1 times x minus 1 plus 7. Well, then from here we can take the negative 1, we can distribute it in, and we'll get y is equal to negative x plus 1 plus 7, or y is equal to negative x plus 8 as the equation of the tangent line to the function at the point 1, 7. Alright, next up we have the same directions, just a new function and a new point. So we're going to find the equation of the tangent line to the function f of x is equal to negative 3x squared minus 5x plus 4 at the point where x equals negative 2. So we'll start off just like we did before. We'll write the equation of our tangent line in point-slope form. And then we're going to want to do some scratch work on either side. So first we need to find the slope. And we need to find the slope, we're just going to take the derivative of f of x. So we can go ahead and do that. The derivative of negative 3x squared will be negative 6x. The derivative of negative 5x will be negative 5. And the derivative of 4, since it's a constant, will just be 0. Now, again, this derivative represents the formula to find the slope of the... let's try that again. This derivative represents the formula to find the slope at any point on our function, but we want to find the slope at x equals negative 2. So that means we'll plug negative 2 in for x. So we'll get negative 6 times negative 2 minus 5, which gives us 12 minus 5, which gives us a slope of 7. Alright, then the next piece of information we need is the point. However, in this particular problem, we are only given the x value. So we know that x sub 0 is equal to negative 2. Now we need to find the y value, or y sub 0. And we know back from algebra that in order to find the y, we just take the input and plug it into our function. So we just need to find f of x sub 0. And we know that x sub 0 is negative 2, so we'll substitute negative 2 into our function. So negative 3 times negative 2 squared minus 5 times negative 2 plus 4. And let's see, we can simplify this out to get negative 12 plus 10 plus 4, which will give us a y sub 0 of positive 2, meaning the point for which we're trying to find the tangent line is negative 2, 2. Now it's time to plug those in. So we'll get y minus 2 is equal to our slope, which we said was 7, times x minus negative 2. Now, before we go ahead and convert this to be in slope-intercept form, I'm going to simplify the minus the negative here. So I'm going to get y minus 2 is equal to 7 times x plus 2. And we can go ahead and get the y by itself by adding 2 to both sides, giving us y is equal to 7 times the quantity x plus 2 plus 2. And we can take the 7, distribute it in, and we will get 7x plus 14 plus 2, or an equation of the tangent line 7x plus 16. Boom, boom, and boom. All right, last question we got is we want to graph the tangent line to f of x equals x squared minus 4x plus 3 at the point 4, 3. So again, here we're not only trying to find the equation of the tangent line, we're trying to graph it. So let's first start off by finding the point on our tangent line at 4, 3. And that means we're trying to graph the tangent line through this particular point. And we'll label that 4, 3. So we need to start off with y minus y sub 0 is equal to m times x minus x sub 0. We are going to have to find the slope. So we'll do a little bit of scratch work here on the side. And to find the slope, we are just going to have to take the derivative of our polynomial. So f prime of x is going to be 2x minus 4. But we're not trying to find the general slope formula for this particular function. We want to find it when x equals 4. So we can substitute that in. F prime of 4 is going to be 2 times 4 minus 4, which is 8 times 4, or just 4. So therefore, the slope of our tangent line will be 4. Now next up, we need to find the point, but fortunately, the question gives us the point. We know x sub 0 is going to be 4, y sub 0 is going to be 3. So now we can just plug it into our equation. So y minus 3 is equal to our slope of 4 times x minus 4. All right, now we do need to get this in slope-intercept form because that is far easier to graph a slope in that form of our linear line. So let's see, what can we do? We can add 3 to both sides to get rid of, or excuse me, to get the y by itself. So we have y is equal to 4 times x minus 4 plus 3. Then we'll distribute that 4 in, giving us y is equal to 4x minus 16 plus 3, or y is equal to 4x minus 13 as our equation of the tangent line. All right, so now if we did want to graph this particular tangent line, we can see that our y-intercept is at y equals negative 13. And that causes a problem for this particular graph because our axes end at negative 2. So we need to come up with another way to graph this tangent line. And fortunately, we have it. All we need in order to graph a linear line is a starting point, which we have of 4, 3, and a slope. Because we know that because slope is rise over run. So I can rewrite 4 to be 4 over 1. That means I'm going to rise up 4 and run over 1. So from the point we're given, we're going to rise up 4, but then we run into another issue of we can't actually go up 4. So that means we need to reverse everything. So we're going to go negative 4 over negative 1. So we'll go down 1, 2, 3, 4, and over 1. And we'll put our second point there. Actually, let's put that in green so it matches. And then all that's left is to draw our tangent line. So that just means we're going to connect these two dots. Shoop, 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 shoop. And there we go. This line is y is equal to 4x minus 13, and we have graphed the tangent line to f of x equals x squared minus 4x plus 3 at the point 4, 3. And there you have it, folks. That is finding the equation of the tangent line to a polynomial at a point.